Another useful integration technique is called integration by parts. It makes use of the product rule for derivatives. So if you remember the product rule, if we have f of x times g of x, I'll just write it as f times g. The derivative is equal to the derivative of the first times the second plus the first times the derivative of the second. So if we have an integral of f prime g, we can write f prime g as f g prime minus f times g prime. So it's a way of converting an integral of f prime g dx into an integral of f g prime dx. This first term here is a derivative of a function, so we can just anti-differentiate immediately for that term. So if we write that out, we then have the integral of f prime g dx, integrating fg prime, so we have f times g minus the integral of f g prime dx. Okay. The usual way of doing this, if we wanted to integrate f prime g dx, is to let u equals g of x, this piece here, and then dv equals f prime of x dx. Okay, so we identify u dv as g times f prime dx. Then we can take the differential of u, so we have du equals g prime of x dx. And we can integrate dv, so we have v then is simply f of x. So this formula then becomes the integral of u dv, right? F prime of x, g of x dx, u dv is equal to fg then would be uv, so equal to uv, minus the integral of fg prime then would become v du. Okay, so this is the formula to remember. The integral of u dv is equal to uv minus the integral of v du. And that just follows from the product rule. If you have a definite integral, then you have the integral from a to b of u dv. So that becomes uv evaluated between a and b minus the integral from a to b of v du. This is integration by parts. So let's look at an example. Let's find the integral. Let's do the indefinite integral of x times e to the x dx. So x times the exponential function. So the key here is to recognize which variable is u and which variable is dv. We would like u to be easily differentiated so that when you take the derivative, the integral will become easier. We know the derivative of x is 1, so that's a very good candidate. So let u equals x. Then dv has to be something that's integrable. The exponential function is very easy to integrate, so we can let dv equals e to the x dx, right? So then we have a u and we have a dv. Then we take the differential, so du is the derivative of x times dx, which is just dx. And the integral of e to the x dx gives us v, and we know that the derivative of e to the x is e to the x. So putting it together, we have the integral of x e to the x dx becomes uv. So here we can just substitute uv. So it's x e to the x minus the integral of v du. V du is e to the x dx. Okay, so we just apply directly the integral of u dv equals uv minus the integral of v du. We can integrate that, okay? So the key here is that x e to the x dx looks like it might be difficult to integrate, but e to the x dx is easy to integrate. So this becomes x e to the x minus the integral of e to the x is e to the x, so minus e to the x. And to that we add an integration constant, c. And then we can collect terms. So this is x minus 1 e to the x plus c. And we've completed the integration. So let me summarize. So integration by parts is a technique that depends on the product rule. The way you implement integration by parts is that if you have an expression such as f prime g dx, and you think it's easier to integrate an expression f times g prime dx, then you can let u equals g of x, dv equals f prime dx, du then is the differential here, is g prime of x dx, and v is the integral here, is just f of x. So the formula to remember is that the integral of u dv equals uv minus the integral of v du. I'm Jeff Chasnov. Thanks for watching, and I'll see you in the next video.